Hello students, welcome to Radhika Smart Classes. Let's start 10th standard with the first chapter of chemistry, chemical reactions and equations. So, chemical reactions and equation. First of all, do we know the difference between chemical change and physical change? Chemical change means change in the composition. Change in composition. For example, like burning. Here I am showing the burning of the wood, or grapes are fermented. When the grapes undergo the anaerobic respiration, alcohol is made, or food is cooked, or digestion happens inside the body. These are all chemical changes, means change in the composition. But when we talk about physical change, only change in state. Change in state. No change in composition. No change in composition, like melting of the ice. Ice melts from water, but it remains H2O. Water heated, boiled, it becomes steam. It still stays H2O. So our first question, we are very clear what is the difference between physical change and chemical change. In chemical change, new substance is formed. New substance is formed. Whereas in physical change, no new substance is formed. Like chopping of the vegetables, or you change the shape of the dough, you mold the clay. These are all physical changes. Now, next is, so when we see any chemical reaction, how do we know reaction is taking place? For example, when a paper is burnt, how do we observe? Heat is coming out. So these are the things, observation which we look for. Change in color, evolution of gas, change in temperature, formation of precipitate. For example, if we add zinc granule in the hydrochloric acid, you will see the bubbles. Bubbles represent the effervescence of hydrogen. So this is one observation which we look for, and we say chemical reaction is taking place. Or evolution of formation of precipitate. For example, if the barium chloride, aqueous solution of barium chloride react with the sodium sulfate, we see the white precipitate of barium sulfate, white precipitate plus 2NaCl. So this is one observation. Third thing is change in temperature. For example, some reactions takes place where your beaker or test tube becomes very hot. It means heat is raising, heat is coming out. That means chemical reaction is taking place. Whereas some reaction where the temperature decreases, your beaker or test tube becomes cold. It means heat energy is absorbed. So these are the things we look for the chemical reactions to takes place. Change in state, change in color, evolution of the gas, change in the temperature, or formation of the precipitate. Now, third question is, how do we write a chemical equation? First of all, what is the difference between chemical reaction and equation? Chemical reaction means when we say word, hydrogen react with oxygen to form water. Equation means symbolic representation. When you write any equation in terms of the symbols, like iron plus water, give you Fe3O4 plus H2. Or if I write in a symbol, magnesium burns in air, it forms the magnesium oxide. When you write any chemical reaction in terms of the symbols, that is called the chemical equation. Left side represent the reactants and the right side represent the products. So now the most important thing about chemical reaction equation is, why do we need to balance? Have you seen when we go to the market to buy vegetables, weight and the weight of the vegetables both should be equal. Similarly, when we have to balance the chemical reaction, number of atoms in the reactants and in the product should be same. For example, we are taking very simple example, magnesium plus oxygen. I will erase it and I will show you. See, magnesium plus oxygen. When magnesium burns in air, it forms the magnesium oxide. So the rules to balance the chemical equation is, first always balance the metals. Magnesium metal, magnesium metal. Both are 1 means magnesium is balanced. Now look for the non-metals. Is there any non-metals? No. Oxygen and hydrogens are balanced in the last. For example, now here how many oxygens are there? 2, but here 1. So how do we balance? Shall I put 2 in the foot or shall I put 2 in the front? What should I do? When you have to balance any chemical equation, we never put any number in the foot, because if you put any number in the foot, what will happen? It will change the formula. So whenever you have to balance, you have to remember one thing, always put the numeral in front. Now this numeral belongs to all the elements with atoms in the compound. Now oxygen is also 2, but this magnesium has also become 2. So I will put 2 here. Now see, 2 magnesium, 2 magnesium, 2 oxygen, 2 oxygen. There is one more reaction, iron plus steam. Water is in a form of steam. It forms Fe3O4 plus hydrogen. Now, how will we balance? First rule, always balance the metals. 1 iron and the 3 iron. So, how many atoms of iron in the product? 3. So, I will put 3 here. Now, C, oxygen. See, now I will balance the hydrogen in the last because hydrogen is alone here. How many oxygen here? 4. Here, 1. Can I put in the foot? No. I should put in the front. Now, oxygen has become 4, but hydrogen has also become 8. But here, how many? Only 2. So, how much shall I put? 4. So, this is a balanced chemical equation. So, these are the rules, and you have to always remember first metals, then non-metals, then oxygen and hydrogen. So, you don't need to show all the working in the exam. You can do in a single step. Otherwise, you can use 2 steps. There are some questions for practice. Tell me, which one shall I do? Shall we do this second one? Let's start. So first sulfur, here 1, but here only 1. So in the reactant, here 1, total 2. But in the product, it is 1. What should I do? Shall I put 2 here? Okay, let's see. Oxygen, how many? 2. Here, how many? 1. Hydrogen is how many now? 2 2s are 4. Put 2 here. Now again recheck. It is very important in the last to check all the atoms. 2 sulfur and 1 sulfur, right? So now it means how many sulfurs are there in the reactant? Can somebody tell me? Yes, 2 sulfur, 1 sulfur. So total 3. But here we have 2. Can I put it here? 3? Yes. 2 2s are 4 hydrogen, 2 2s are 4 hydrogen, 2 oxygen, 2 oxygen. So it is balanced. Shall we try one last? Okay. How many chlorine are here? 1 metal, 1 metal. 1 aluminium, 1 aluminium. Now, second step is non-metal. How many chlorine? 3. Here, 1. Shall we see here? 3. But how many hydrogen here? 2. But here, 3. So now see, this is one small trick. When both are prime numbers, take the LCM. 2 3s are 6. So 3 2s are 6. So I have to make it 6H. So what will I do? I will erase this and I will put 6HCl. 6HCl, right? So now how many chlorine? 3. Now here 2. Now 2. Sometimes we have to start from the metal, but slowly after balancing, we have to come in a reverse order. Got it? Rest of the reaction you can go for yourself. Now, whenever you have to write a chemical equation, remember some important points. Physical state is very important, whether it is a solid, liquid, gas, precipitate. Solid is written as a S, liquid is written as a L, gas you can write the first letter G or capital upward arrow, and for precipitates you can write PPT or downward arrow. Precipitates are nothing, this is an insoluble solid. Best example you see now in home, when mama makes a paneer from the milk, when she put a lemon juice or citric acid in the milk get precipitated, that paneer act as a precipitate. And the second thing which is most important writing the chemical equation is if there are any particular conditions, any particular color or any particular smell, odor, anything. Now, here is a first blue box which is very important. Why should magnesium ribbon be clean? We will do now. These are the balancing. Try yourself. Please do this question yourself. And these are the word equations. Very important. This second equation is very important. Here this equation is very important. Please do it by heart. If there is any doubt, you can DM me. Now question arises next types of the chemical reaction. Understand, we divide the chemical reaction on the various bases. First, let's describe the chemical reaction on the basis of heat released and heat absorbed. When I talk about the heat released and heat absorbed, what do you mean? The reaction in which heat energy is released, they are called exothermic reaction. What are they called? Exothermic. Exit means out. Exo means exit means out. You go to the theaters, there is a written word exit means out. So heat energy is given out. Heat absorbed, the reaction in which heat absorbed, endothermic, in endothermic. So now my question to all of you is, when the reaction takes place, we can't see heat energy is coming or absorbed. How do you find whether a reaction is exothermic or endothermic? See, there are two ways. When the reaction is exothermic, when the heat energy is given out, your beaker or test tube will become hot. And when it is an endothermic reaction, energy is absorbed. Energy is absorbed. Your beaker will become cold. Endo, D letter, absorbed, D letter, cold, D letter. So remember this. We will learn more reaction about exo and endo as we will move further. Now, types of chemical reaction. So we have a combination reaction, decomposition reaction, displacement reaction, double displacement, and redox reaction. So first of all, we will learn the first reaction, combination reaction. We will learn the first reaction, combination reaction. But before going to the combination reaction, I want to ask, how does the reaction takes place? What is there? What happens in the chemical reaction? In chemical reaction, what happens? Some bonds break down, some new bonds are made. For example, ask you very simple thing. I have a word CAT, cat. Can you make any other word with these same letters? Yes, I can make act, tack, right? Similarly, in a chemical reaction, there is no new atoms come. Only there is a rearrangement of the atoms to form the new products. Some bonds are broken, some new bonds are made. So chemical reactions involve breaking and making of the bonds between the atoms to produce the new substances. So let's learn first combination reaction. Now, when we talk about the combination reaction, what does it mean? Please mark this. This is the definition. Combination reaction means when two or more substances Now, what do you mean by word here substances? It can be elements or it can be compounds. It can be elements or it can be compounds to form a single product. When two or more atoms or compounds combine in a fixed ratio to form a single product, that reaction is called a combination reaction. For example, hydrogen plus oxygen. What does it make? Water. Now, this is a gas, but this is liquid. But here, is it a balanced? No. Whenever we write a chemical reaction, it should be balanced. Right? Second reaction, carbon plus oxygen, carbon dioxide, nitrogen plus hydrogen. These are all combination reaction, right? But now these are all atoms are combining. Can we write one equation where compounds combining? Yes. Calcium oxide. Do you know what is calcium oxide? Chuna. When it is dissolved in the water, it forms slate line, calcium hydroxide. And this reaction, here calcium oxide is dissolved in water very vigorously. This reaction happens very vigorously and it gives out the heat. So when the heat is given out, what is the example? It will come under the, if you will see, heat is given out, it will come under the exothermic reaction. So here we cover the pot with a cloth because our pot or a beaker becomes very hot, and it is a self-balanced reaction. See, here are the example. This is a very important reaction. Calcium oxide react vigorously. Please remember, vigorously is a star word. Calcium oxide reacts normally, vigorously. What is the right word? Which is the right statement? Vigorously with water to produce slate line. What is another word for slate line? Calcium hydroxide. Releasing. Releasing means it is an exothermic reaction. So this reaction belongs to combination, this reaction belongs to exothermic reaction. And it is a self-balanced reaction. Calcium oxide combines with the water to form single product calcium hydroxide. These are the other example, carbon plus oxygen, hydrogen plus water. Now, I told you we will learn more about the exothermic reaction. Please understand, exo and combination reactions are linked. It's not that only combination reactions are exothermic. Even displacement reactions are exothermic. So, respiration, where our food is broken down with oxygen to give you energy in the form of ATP, that is also a exothermic reaction. This is also very, very important question. Respiration is an exothermic reaction. Explain. The carbohydrate, which carbohydrate? Glucose, is broken down with the oxygen to give you carbon dioxide, water, and energy is given out. So respiration is an exothermic reaction. In the exam, it is like a 2 marks question. If they ask you respiration is an exothermic reaction, justify or explain, you have to write this 2 lines ki food is broken down with oxygen to give you heat in the form of ATP. Which energy? ATP. Second most important thing, writing the reaction is very, very important. Writing the reaction is very, very important. If you will not write the reaction, if you will not show, we will not score marks. Let's move ahead. So this was all about the combination reaction. Next is the decomposition reaction. As it is clear from the name, decomposition. Anybody? Decomposition reaction means breakdown. Decompose. We have to break down the compound. Single compound is broken down into two or many products. But how can we break down the compound? We can break down with the heat. We can break down the compound with electricity. we can break down the compound with the sunlight. So first reaction, which is most important, it is a thermal decomposition. Thermal decomposition reaction. Thermal means heat. Everybody is clear with the word. Thermal decomposition reaction in which compound is broken down with heat. Compound is broken down with heat. So what is the symbol of heat? We put a triangle. So this is the activity where ferrous sulfate crystals. What is the formula of ferrous sulfate? FeSO4. FeSO4, it is also called the green vitriol. What is it called? Green vitriol. NCERT has not put a green vitriol. They have started with anhydrous. Please, we will start with the green vitriol, ferrous sulfate, 7 water. It is called the green vitriol. It is called the green vitriol, right? So when it is heated, what happens? First, these 7 water molecules evaporate. It is a green color. It forms ferrous sulfate, anhydrous, without water. Anhydrous means without water. Now it has become colorless. It has become colorless. Again, it is further heated up. It will give you Fe2O3 plus SO2 gas, upward arrow, plus SO3 gas. So SO2, now what is the characteristics of this reaction? First point, we have to balance. Put here 2FeSO4. Now, next is, what is this? Is solid. It is reddish brown. What is this? Reddish brown solid. Please remember the characteristic, because sometimes they will ask you the question, what happens when green vitriol is heated? Write any 2 observations. First observation, reddish brown solid. Second observation, pungent smell. Which compound give you pungent smell? SO2. SO2, pungent smell. So this is one of very important question. So it is written here in the detail. I have just explained in the one line. Now, second example of thermal decomposition is calcium carbonate. Do you know where do we find the calcium carbonate? Eggshell, marble, chalk. If you will heat it, it forms calcium oxide plus carbon dioxide. So carbon dioxide is our gas. This is solid. This is solid. Third. What is the third example? Lead nitrate crystal. This example, activity 1.6 is very important. Either activity 1.5 will come in the exam, or either activity 1.6 will come in the exam. Without these 2 activities, your question paper is incomplete. So we take a lead nitrate crystal. Lead nitrate crystals are colorless. Please remember the color, colorless. So you heat it. So when you heat it, what will it form? PbO, solid, plus NO2, brown fumes, plus oxygen, Shall I tell you the trick to remember the balancing? See, first metal, one lead. How many nitrogen here? 2, but here only 1. Here 6 oxygen, here 4 oxygen. So, and 1 here, 5 total in the product. So, best way to remember this, remember one coefficient. Please remember one coefficient. Thermal decomposition of lead nitrate, remember one coefficient. 4NO2. Never learn the NO2. Always remember 4NO2, brown fumes. Now, how many nitrogen? 4. But here, how many? 2. Can I put 2 in the front? Yes. Now, how many lead? 2. But how many here? 2, 1. So, it is balanced. 3 2s are 6. 6 2s are 12. Total oxygen 12. Here, how many? 4 2s are 8. 8 plus 2, 10, 10 plus 2, 12. So this reaction looks tough, but it is very easy if you remember one small trick, 4NO2 brown fumes. And what is the second observation? This is a yellow solid. This is a yellow solid. Very easy. Now I am giving you two questions you have to do yourself. What will happen if copper nitrate crystals are heated? And second, magnesium nitrate crystals are heated. It is same like a lead nitrate, but I have changed the metal, copper nitrate and magnesium nitrate. Please complete. So this is all about the thermal decomposition. Green vitriol, calcium carbonate, lead nitrate, copper nitrate, magnesium nitrate. Second type of the decomposition is electrolytic decomposition, where compound is broken down with the electricity. So what is the example? Water. Water. So when the electricity is passed through the water, it will break down into hydrogen and oxygen. It is called electrolytic decomposition. When you break down any compound with electricity, we have two electrodes, cathode and anode. See this figure, 1.6 in your NCERT, electrolysis of water, which is very important. They will show you the figure and they will create a 1 mark question A, B, C, D. So first of all, we take a distilled water. We never take a tap water because the impurities will interfere in the reaction. But as we know, distilled water does not conduct electricity. We add few drops of the acid. There I have written add few drops of the acid. Why? To conduct the electricity. Second, now we have made electrode and these electrodes are made up of graphite. Why do we take a graphite? Because graphite is a non-metal. It does not react with water. It does not react with water. It is inert. Now, current is passed. So the terminal which is attached to the positive terminal, that is called anode, which is attached to the negative terminal, that is called cathode. So when the current is passed through the water, what happens? Water will break down into hydrogen and oxygen. Now question arises, will the hydrogen go to anode or cathode, or oxygen will go to anode or cathode? How do we remember? Always remember, metals go towards cathode and non-metals anode. Non-metals are negative, so they will go towards the positive. And metals are positive, they will go towards the cathode. Oxygen is non-metal, so it will collect at the anode, whereas hydrogen will collect at the cathode. Okay, so first part is done. Second part, is this reaction is balanced? No, let's balance. So what is the volume ratio? So second question is, what is the volume ratio? Hydrogen is double as that of oxygen. So if you will see here, there is a lot of space empty here. Here is a less space. Why? Because volume of the hydrogen is more. Volume of hydrogen is double. So hydrogen is 2 parts, whereas oxygen is 1 part. So hydrogen is more, oxygen is less. Next, mass ratio. What is the mass ratio? Everybody learned in a 9th standard, in hydrogen and oxygen in water, 1:8. Now, last question, how will you identify the gases? Because hydrogen and oxygen both are colorless. Next is hydrogen. Hydrogen is a very flammable. It catches a fire quickly and it burns with a pop sound. Where oxygen does not burn itself, it will support the combustion. So if you will bring the burning candle near the hydrogen, it will burn with a pop sound like a popcorns, and oxygen candle will burn brightly. So this is still here. We have done the electrolytic decomposition. So we have finished till here electrolytic decomposition of water. One thing I want to tell everyone here, Please, these activity question, be thorough with them. And they have asked in these activity questions some questions, these activities. What happens in each case when you bring the candle near the oxygen and hydrogen? Which gas is present in each test tube? Please do these questions. If still you are not clear, you can subscribe and ask me in the comment. Now, third type of the decomposition is the photolytic decomposition. Photo means when you break down the compound with the sunlight. When you break down the compound with the sunlight. See, we have done the decomposition with the heat, thermal. We have done the decomposition with the electricity, electrolytic. When you break down the compound with the sunlight, it is called the photolytic decomposition. So this activity 1.8, please note down, it is a photolytic decomposition, right? So in this case, we have the two examples. What are the two examples? Silver salts, AgCl and AgBr, silver chloride and silver bromide. Both are solid. If you expose the silver chloride in the sunlight, it is itself is a colorless. It will turn gray. It will turn gray. So it means there is a change in color, means reaction is taking place. Here AgBr is a silver bromide is yellow in color. So again it will turn gray in color and chlorine gas will come out. So these reactions are called photolytic decomposition reaction. So silver salts are always stored in a dark color, amber colored bottles. Why? Because these salts are very sensitive to the sunlight. And these reactions are used in the black and white photography. Please remember what is the use of these reactions? Black and white photography. Best example is in the olden times we have a camera rolls. They have a coating of a silver. So whenever you open that roll in front of the sunlight, photo used to be ruined. So why? This is the only reason, because they have a silver coating and silver salts are very sensitive to the sunlight. So decomposition reaction require energy. Require means absorb energy. Require means absorbs energy in the form of heat, light, electricity for breaking down the reactants. So these reactions are also known as endothermic reaction. Either it is a thermal, electrolytic or photolytic, they are all endothermic reactions. But remember one decomposition reaction which is exo also. It is written here. Please remember this decomposition reaction on the page where we have learned that this decomposition reaction where vegetable matter change into the compost is a exothermic reaction. All these decomposition, photolytic, thermal decomposition, electrolytic, they all are endo, but breaking down of the vegetable matter into compost, that is an exothermic reaction. So guys, we will stop it here today. For the next part, please follow me and we will continue the chapter in the next class. Thank you.